So in this video, I'll be showing you how to use the UltiBridge tool, which is a Blender to Unity to Godot to Unreal exporter. And it's a bit special because it supports all three, and it supports a few things you don't normally see, like LODs, colliders, and materials. It also supports instances and lights, cameras, curves, text objects, everything you would ever need as a level designer. And that's the target audience here. If you're a level designer and you don't like doing stuff in Unity, Godot, Unreal directly, you can just do your level design in Blender and have this add-on reconstruct your work basically in the engine. And that is very nice if you don't want to, you know, have to work with those engines for one reason or another. But that's pretty much everything. So let's start with this cube. Actually, no, this cube is too simple. Let's start with something more advanced because that's how you can tell that everything is working. So let's go with this sci-fi lab. It looks pretty good and it has a lot of textures and things. If you have a big scene like this, which is almost a half a gigabyte, it might of course take a while to export from Blender to your engine, but that's besides the point. The point is to show that even complex scenes and more importantly, good-looking scenes can be exported without any loss of quality. Okay, once you have your scene, you should probably have something like this. Looks good. Let's go to Eevee to make sure that it's not too grainy. And looks good. This has a bunch of transparent materials, which is perfect. Normals, you know, the PBR stuff. Everything is here as you would expect. So let's go to UltiBridge and let's use Godot for our first example. I'll go through all the engines, but let's start with Godot for now. So you simply go to your Godot instance, and let's delete the add-ons because I want to show it from scratch. And you go to File Manager and you just copy this path. That's the path for your project, and that's the path this tool expects. It should detect the version and the script version as well. So the first thing you need to do is install tools, like so, and it should have this check mark. Then you go to Godot, you do reload from scripts, you do projects, and you make sure this is enabled. It's usually disabled by default, but make sure it's enabled. And now you're good to go. Now Blender and Godot are basically communicating. So all you have to do in this situation is just click this button. And that's it. It can take a while. This is half a gigabyte of textures and meshes. So, you know, be patient. Once you see this send scene to UltiBridge, send scene UltiBridge to Godot, that means that the file has been made. So now you have to go to Godot, and Godot will import everything in this pack we just made. And once you're done with this, it will import the FBX files. And if it starts to increment a lot of messages like this, then you have to double click Godot. It's just a quirk with Godot itself. That's the fix currently for this issue. And once everything stops, the scene should load up. And once the shaders are loaded, everything should look good. If the scene doesn't load, you go to this folder, or you go to scene, and you should see this scene file here. And here we go. Then you can clear the console, and you should be good to go. But you may notice a few differences. One, for example, is that the transparency isn't working. And that's because you have to tell Blender exactly what is transparent and what is not. Because there are three modes of masking for shaders. You can have masked transparency, you can have a translucent transparency, and you can just have opaque. So you go to UltiBridge here and you can choose per material which you want. And in this case, it's translucent or transparent. And everything that looks like it should be transparent, you can just quickly go through here. I think this shelf should be transparent. And I think that's everything. So now we can just export again. And this workflow is the same for Unity and Unreal, but I'll show you the differences after I'm done with the Godot one. So you shouldn't skip, because most of the stuff I do in Blender, for example, is the same for Unity and Unreal. So again, once you have clicked the send button, you just go to your engine and it will reload the scene. And as you may see, nothing changed. And that's because you have to reload the scene. And there we go. Now everything is transparent and it looks pretty much one-to-one with what we have here. And in Godot, it also recreates all of the FBX files as separate FBX. So you can, do stuff with this even after you're done with the scene. It also creates a prefab or an instance for each object, so that if you copy one of these objects, it will still be linked to the same instance, so you don't get duplicates. You also get one shader per material, which tries to match the Blender shader graph as close as it can. In Unity, it's the same, it just uses HLSL, and in Unreal, it's shader graph, but the workflow is pretty much identical. And here we have the textures, and everything is instanced, so there are no hard-coded, or nothing is really saved into the scene. Everything is like referenced to each other, which is very useful. Now let's go to the instancing. So if you have something like this, you have a table and you don't want a new FBX file for this table, you can just select everything on this table like this and do Alt-D, and it will make a new object. But if you go to the mesh data, you'll see a number 2 here, or you might see an increment of whatever number. You might have a lot of these. Let's add a third one so that it makes more sense. So in this case, we have 3 tables, and that means 3 instances of each. And this is useful because now we have a single, I'll show you. The amount of FBX files is less than the actual amount of objects. So we don't create thousands of FBX files. You can imagine like a forest of trees. You wouldn't want a FBX file for each tree. So this would be basically the solution to that. It handles instancing for all the engines. Another thing is that if you have colliders, you can make those. So let's add a simple collider to this table. So just make some kind of mesh, and I'm gonna do this real quick here. You can also do this. You can copy the mesh like this with Shift D, and you can go to edit mode and do hull, and it will make this kind of shape that kind of matches our table. So now you just parent it to your object like that, and it's gonna move. So you have to make sure it's keep transform, so it stays with the table. And I think I did the inverse. So let me clear this. Keep transform and parent this to this instead. So now if we move, I still did it wrong. So you have to have there we go. So you have to have the root object as the active object. So clear the transform. Actually, I can do this. I can just set the origin. So now we have this rudimentary collider here, and you may notice that if you refresh this, nothing really happens. And that's because of the naming scheme. And the naming scheme is the following. You have UCX underscore you have the object name, and then you have a number starting from 0, 00. And now if we go here, we can see that there's a single collider. And we can do an LOD as well. So if we duplicate this and we parent it to our table, we just do the name of the object and underscore LOD 01. So if we do refresh, we can see that an LOD is detected. The collider just disappeared because we have it hidden, so make sure that everything is visible, otherwise it might not get exported. That's pretty much for creating your own colliders and LODs. Of course, if you really did an LOD here, you would have to also decimate it, make it a simple representation. If you don't want to do this manually, you can of course buy the other add-on, which is the COACD add-on, and this will just generate the colliders and LODs for you. It can save a lot of time if you have a lot of objects, and the LODs come from this button. So we have to make sure they're enabled, and there we go. So now we have 3 levels of LOD and 8 colliders. So if we go back here, we have as you would expect. And the thing is that now that we have this table instanced, you have this number here, it means that every single instance will use the colliders and LODs. So it's you don't have to make it for every single object if you use instancing. So now you just send to Godot in this case. So once everything is loaded, nothing changes, because if you have the scene already loaded, it won't automatically reload. So you have to go to your scene and just open it up again. And now we can see that we have the tables. And if you look closely, you see this circle, and that usually means it's a hierarchy. And in this case, the hierarchy is that it has LODs and colliders. So if we go into one of these, you'll see that it's flipped. I'll show why it's flipped. But if you look closely, you can also see the actual individual colliders. And if we... This is a bit hard to see, but with good LODs, you can't really see them. But I'll try to make this visible. So the LODs basically just seamlessly switch between each other. But you may notice that this one has fewer polygons. It's really hard to tell because it's a square, but some of the edges are a bit weird, and that's because of the LODs. So everything works. If you have LODs, they are indeed, if you have colliders and LODs, they're indeed there. And if you hover over, you may notice that all of these are using the same instance. So that if you go into the prefabs folder, you have all these instances, and all of these 3 are using the same instance. If you modify this, all of these will be modified. So it's basically the best you can get with Godot as of now. And it mirrors the workflow in Unity and Unreal as well. So if your prefabs are flipped, it's usually because of the root object. Everything here is parented to this table, and this table just happens to have a initial rotation like so. So if we delete this, everything gets flipped. So just get rid of that before you do stuff like this, or otherwise this rotation information will be baked. Even in this case, we have a rotation here. The scene compensates for it, but you don't really want it to be on your root object. But that's intentional. Sometimes you might want to have a rotation like that. If your material does have a occlusion node, the GLTF shader comes with an occlusion node, but if you do want to add it yourself, you just go here and add the bridge group, and you just connect your occlusion image or whatever you have into this, and it will recreate the material using that. So now let's go to Unity. So for Unity, let's pick the latest version, 6000. It will work from 2021. I will actually put a list of supported versions in the product page because it will change, and you know, just read it. That's the up-to-date list of supported versions. So just like how we did with Godot, we get the path like so, and we copy the path to our bridge tool, and it will detect it as a Unity instance. But otherwise, the workflow is exactly the same. So if you do install tools, you go to Unity and let it load, and do yes if you do get this. And once you're here, you have an editor folder. That's a sign that it's installed. So now you go back to Blender and you just do send to Unity this time. And once it says send to Unity, you just open up Unity and it will load. Go. If it freezes, then you might have to double click Unity to make sure that it actually goes with the import. Sometimes it will freeze because of the scripts, but if you double click, just like how you did with Godot, it should resolve itself. And here we go. And it's pretty much the same. There is not much to really say, but I'll go through the objects here. So it's a bit different in Unity, of course, because of things are a bit different, but you have a materials folder and each material has a shader, and each shader is made with HLSL. So this is the shader code you would expect. Other than that, each material has its textures assigned, like so, and everything has a prefab, so you can instance things as pretty easily. And you have the actual FBX files as well, and the textures. But it's pretty much, other than that, it's identical. You have the, here the LODs are a bit nicer. Unity has actual component for this, so it will switch between the objects. And colliders work in this way. So each collider is a component, basically, or a game object, and each game object has a mesh collider in the convex mode. But that's pretty much the only difference. Otherwise, it's identical. Let's go to the Unreal version now. Unreal, it's a bit different. You have to install the tools before you open up Unreal. So find your folder with the U project and just go to Blender and set the path. And you should only have one engine at open at once. It can cause issues. So let's install the tool. And then you just go to your project folder. You can do shift left click on the icon here to open it. And that should be it. So once you have Unreal open, you can go back to Blender and it should detect it. And now we just do the same as it with Unity and Godot. We just click send to Unreal Engine. And then you open up Unreal. And there we go. Everything looks pretty much one-to-one. The difference, of course, is that the scenes in Unreal don't really have any lights, so you would have to, if you toggle this, you'll see the problem. Well, actually, due to Lumen, the emission will carry this scene, and that's pretty much it. The differences are the following. So there are no shaders in Unreal. You only have the material, and the actual shader graph in here. That's the only shader. But they should be 1-to-1 with Blender. So you should be fine with that. The textures are, of course, in their own folder, and the meshes are here. And I think the table was mesh number 14. So let's find it. So here we go. So if we hover over, we can see that it has 4 LODs and 8 collision primitives. None of these other ones have those. And if we go to here, we have the same issue with the rotation, and that's because of the empty. So you have to make sure the initial rotation of your objects is, or the identity transforms of your objects are basically, you can only see it with this one. Make sure this is 0. So if you apply rotation, for example, it would fix the issue. But you would also lose the instance link, so you would have to link the instances again. With Control L, but then the rotation breaks on these. So you should really do it in the beginning, otherwise it will carry here. But you can visualize the colliders by going to player visibility, and the LODs are here. It's very hard to see it, but you can see the triangle count change. So that's a sign that everything is indeed working. You shouldn't be able to tell LOD changes anyways. It's pretty good. One last thing is that there is this, if you look at the top left, there is the screen size. And you can control this screen size parameter for your LODs with this. So it goes up to 6. You shouldn't really have 6 LODs. If you have a reason to have more, then send me a message in the Discord channel and we can figure out something. And that goes for any issues. If you have any issues with the add-on, please tell me, because there are so many versions of Unity, Godot, and Unreal that I cannot go over them, all of them. I go over the major releases, and I'll try to keep track of the supported versions in the product page. But if you do have issues, then please join the Discord and send me a ping. Then I can help you with your specific problem. But that's everything this add-on has to offer. So I guess go crazy. It can really help with level design, as it will preserve the hierarchy. So you don't have to. Let's say you're a level designer for all 3 engines at the same time. It would be very annoying to have to learn the level design tools for all 3 engines. So this is a shortcut, basically, for that problem. But that's pretty much it for this video. Hopefully you like it. If you have any questions, you can put them in the comment section of this video, and I'll try to answer them. Otherwise, join the Discord and we'll figure out if there are any problems.